Today we're going to be determining independence. Initially, we are going to be using this formula to make sure you remember how to use it. And then I would like you to recall how to figure out this formula. Remember, intersection is the and. It's this one that looks like an A without the line through it. And it's just simply multiplying the two probabilities together. So the first kind of a question that I'm going to ask you is, Andrea is a very good student. The probability that she studies math and passes her math tests is 17 out of 20. The probability that Andrea studies is 15 out of 16. Okay, find the probability that she passes given that she has studied. So we don't have a lot, we have numbers, but all we have here is probabilities, and they're kind of different probabilities. They're not related to each other, really. It doesn't seem like it directly. But we can use the probability formula for given, which means the probability of the and over the probability of the given. And that's what the formula says up here. That's what the formula says right here. This is the and, because it's upside down, divided by the probability of the given. So when I write this, it would be the probability of A given B. So that line that's straight up and down, that means given. So we just do that. The probability of the and, which is 15 out of 16. The probability of the and is 17 out of 20. She passes and passes her, she studies and passes her math test. And we divide that by the given, so just that she studies. Do that math, and you should get 68 out of 75. Now, you should leave it as a fraction, not as a decimal, because sometimes if you put this in certain ways, you'll get a decimal. I know it is around 91%-ish, but that's rounded. So no rounding was talked about, so always leave it as that fraction. So try this one, take a second, and we'll come back with the answer. So you should have gotten 8 over 9. So hopefully you did that. Remember, this is how it works. 4 over 15 divided by 3 over 10, because the and goes on the top and the given goes on the bottom. So it says given that she smokes. So she smokes is 3 over 10, so that should be on the bottom. So we remember independence means does one probability affect the other? There are two ways to prove or determine if two events are independent. Now, this says the probability of A is equal to the probability of A given B. So remember that line right there means given. So that means that it's basically saying the probability of A is equal to the probability of A whether or not B happens or not. So probability of A is equal to the probability of A given B means that B had no effect. And with this one, probability of A and B is equal to the probability of A times B. If that happens, then they are independent. So if you multiply the two individual properties together, probabilities together, you should get the and exactly back. So let's use these formulas real quick. So determine if these events are independent. So you're trying to determine if A and B are independent. So in this particular case, they're telling you A and B. Remember, that's the and. So they're telling you A and B is this, and they're telling you what probability of A and probability of B is. So since they're giving me the and one, I'm going to use the formula or the proving that uses the and. So it says that the probability of A times B is equal to the intersection. So let's do that. The probability is A is 3 over 5, B is 13 over 20, and then them together is 39 over 100. So what we have here is this true? So 13 times 3 is 39. So I wrote too big here. So it's 39 over 100, doing this math right here. And that is 39 over 100. So check, independent. Okay, and this is a, we like to say this is a justify. So here I am justifying. Remember, justify means use math. So if I could use words, that would be explain. But here I'm using math to justify. All right, so this one here also has an and, so I'm going to see if 3 over 5 times 3 over 5 is equal to 39 over 100. Is that true? So this is 9 over 25. Is that equal to 39 over 100? Maybe you want to reduce, see if you can, but nope, these are not. So not independent. You can also say dependent. So here we go. This one's easier. This one's easier in general, but should be, sometimes it's a little weird to see. So this is the one that uses the given. So this is the probability. It says that probability of A given B is equal to the probability of A. So what's A given B? Well, that's 7 over 10. Probability of A is 7 over 10. Check, independent. That's it. So there's really no math involved. You just have to set it up right. So probability of A given B is 3 over 5. The probability of A, so it's always the first one, is 9 over 20. So not independent or dependent. So I'm telling you right now that they are independent, so meaning all the probabilities work. Well, those two proving things work are true if we want to find the missing probability. So I'm telling you that it's that they are independent, so I know that the probability of A given B, which is 11 over 80, should be equal to the probability of A times the probability of B. But I don't know what that is. So you simply have to do the math. So either divide by 1/4, multiply by 4, whatever it takes to get the answer, and you're good. So this is 11 over 20. Okay, try it with this one. Same deal. This one uses the and. Oops, sorry, I put the A there. But that one uses the and, so take a second and see if you can figure that out. Okay, so this one should be 1/4. I mean, you could do these in your head. Like, you don't necessarily need to divide, but, you know, in the end, you should get 1/4, and here's the work. Right, so for this one, they're telling you that they're independent. So they're telling you that the probability of A given B now. So that means that the probability of B given A, so B is 3 over 10, that should be equal to the probability of B. So that should be X. So it's just 3 over 10. It's almost like too easy, truthfully. And then this one here, so what do you think this guy's answer is? Okay, so that's an excessive amount of writing for what just happened. Probability of A given B is 11 over 20, so the first one is A, so that should be equal to the probability of A. So it should be 11 over 20. That only works because these guys are independent. So let's take a look at this. You have a little chart here, and we want to determine these things given the chart. So we used formulas, and now we're going to determine independence given, you know, actual real information. So find the probability that a random dog selected is a basset hound. So basset hounds, there's 22 of them. Okay, over the total. So when we do probability, it's always over the total. Now, the only time that changes is when we have a given. Given that it is a basset hound. Right? So that means that that's the bottom. So it's 22. And then male, so we have to do the intersection of A, male, and basset hound. So right here, 10. So that's the probability given that it's a basset hound, so that's why the bottom number isn't 44, because there's 22 basset hounds. And 10 is how many male basset hounds. So now we want to determine if being male and being a basset hound are independent events. So we need to know two things. Oh, well, we could do it the two different ways, but seeing that we've already, in this point, figured out what it means to be male given that it's a basset hound, let's do that one. Male given a basset hound. So we're going to write that. wow, she's working it today, that should be equal to the probability of it being a male. And if that works, then we have to do it the other way. The probability of being a basset hound, given that he's male, is equal to the probability of being a basset hound. However, if I figure out this one and they're not independent, then I don't have to do the second one. So male given basset hound is 10 over 22. We just figured that out in part B, right here. What is the probability of being male? Well, there's 24 males. There's 44 total. Are these two equal? No matter how I reduce them. This one's actually 12 out of 22. If you reduce it to have the same denominator so you can see it. And so this one, they are not independent. Or they are dependent on each other. So if this turned out to be true, I would then have to figure out that one. All right, have a good day.